So I am here less providing expertise on the neuroscience, more want to learn about it and then think about how some of the advancements in AI are relevant to the field and how some of the advancements in brain-computer interfaces and whole emulations might correspond to AI. So I have experience working on large-scale machine learning applications, mostly in model evaluation, data labeling, and data annotation. I also have some experience going back a few years on ECOG applications, so signal processing. And I have some questions that I put up here that I would want to get your feedback on. So how can we use machine learning techniques to improve our progress towards whole brain emulation? What are the major bottlenecks? So I already had some discussions with a few people. It seems like stitching images, labeling is a big bottleneck that right now requires skilled human labor that machine learning might be able to take a chunk out. And filling in gaps or error correction. So any process of scanning and imaging is likely to be faulty. Machine learning might be able to generalize and fix that over. That we need to see, we need to work hard on it to actually see advances. And then some places where BCI might help in alignment research. So the main idea I'm aware of is just increasing the bandwidth for reinforcement learning from human feedback. Right now, it's a fairly low bandwidth, but actually, professionally, I work with the same company that OpenAI works. It's mostly a large group of people in Nigeria who sit in front of the computer, see pieces of text, and then say yay or nay. One, that's not very representative of the whole human experience. How can we broaden that? But then also, how can we get much more bandwidth and get a more complete understanding of human values and send that to the actual algorithms that we are working on optimizing. Of course, a more pie in the sky dream, increasing human capability. So as we actually go further in both brain-computer interfaces and whole brain emulations, we ourselves might be able to increase our capability, which makes us both better at solving alignment problems, but potentially also capabilities. And now I'm going to mostly open the floor I want to hear other people's takes on those questions and see what I have wrong, where should we focus on.
Thanks.
Yeah, so any feedback? Any opinions? Yes?
I mean, has anyone done just like even a toy case of using BCI to help with alignment, like even a toy problem, maybe even with some sort of BCI that's not even a high resolution? Toy experiment?
So I know there's a couple of people who are just starting out. So I know someone who's working on using EEG and seeing if there's anything that we can get from that. There's a couple of people who are working on even lower bandwidth. So right now the state of the art is mostly just saying approve, disapprove. And there's a lot of places in between that and actual brain-computer interfaces. They tend to have a scaling issue where the more bandwidth you have per person, because currently you're paying mostly by the man hour. So you want to minimize the amount of time people need to spend on actually giving feedback. So that's why I'm specifically looking for how can we automate getting higher bandwidth feedback. But the efforts are just starting to happen right now.
Who's doing it?
I don't have the name off the top of my head, but catch me later and I will send you. And I'll add a link on the doc.
Well, with that being said, I want your challenge.
Yeah.
What's your challenge?
Yeah, so I'm going to put the how can we get higher bandwidth human feedback using neuroscience.